Yeah guys, in this video session we have to see about the addition part. That means in different number systems how we can add those numbers in efficient manner. For an example, we'll consider about the decimal number system, 739. So this is a decimal number. I'm putting the base as 10. And also 27. So this is another number, base 10. We have to add those number here. But the thing is, once you are doing this addition activity, you have to consider the particular thing. That is, you have to manage all of the numbers in the same base. So in here, you can see this number is also 10 base. Then this number also the decimal number. So regarding to this calculation, we can do with any errors because these both numbers having the same basement. Base 10, base 10. So that's enough. Once you are having a different numbers, then you have to convert those numbers into the same basement. Then only you can add those value for the addition part. Not only the addition part, but also subtraction or multiplication, any other calculations, you have to do so far. So 9 plus 7, 9 plus 7, that's equal to 16. In general term, we don't have any spaces to write base 16, sorry, base 10, 16. So that's why we'll write 6 here and 1 will be the remainder. 3 plus 2, that's equal to 5. Then the remainder 1 will be added with these numbers. And finally, you can write the number as 6 because 3 plus 2, 5, then remainder 1, so 6. Then 7 will be here. So this is the correct calculation in the decimal format, but you all are familiar with this calculation. From our childhood, we are doing like these calculations. Very simple. But the thing I have to explain is why we are writing this one. So 9 plus 7 means 16, right? So this is base 10 number calculations. Initially, we have to divide by 10. So one time we can divide this number totally, then the remainder will be 0. Sorry, 6. So the remainder can be written here. So 6 will be written here. So this is the quotient part, right? The totally we can divide 10 into 16 then one time. So the 1 will be added as the next calculation part. So 3 plus 2, that's equal to 5. Then this 1 will be added here. Then 1 plus 5 is equal to 6. Because 6 can be divided by 10. So 0 times totally it can be divided because 6 is less than 10. Then the remainder will be 0. So this remainder will be written here. You don't have to add any values with the previous one because the 0 is the quotient part. So we don't have any need to write here. So 7 you can directly write as 7. So this activity is happening in this number system addition part. But the thing is, once we are having a different number systems, we have to divide the particular numbers by the different numbers. That's the thing only you have to follow. So this one is simple, right? Then I'm clear this all the elements in this window. The first activity I have to do is 1, 0, 1, 0, 1, 1. So 1, 1, 1, 1. These numbers in binary number system. First thing we have to do is how we can add these numbers in binary number system. So once we are worrying about the number system's addition part in binary, we have to know about these calculations. 0 plus 0, that will be 0. 0 plus 1, 1 plus 0, 1 plus 1. Sometime you may get 1 plus 1 plus 1. Only the thing you have to memorize is this. 0 plus 0 means 0. 0 plus 1 means 1. 1 plus 0 also 1. Once you are having 1 plus 1, you can write 0 But the thing, you have to add the remainder with the previous one. So this one is the remainder part. This one will be carry, C-A-R-R-Y, carry. Carry means you have to add the particular value with the next calculation. So 1 plus 1 plus 1. That will be 3, no, in decimal number system. But 3, you don't have any spaces to write 3. So you have to divide by 2. So one time it will be totally divided. You will get the remainder as 1. So the remainder part you can write here. No? So 1 will be written here. Then the carry part will be 1. Once you are having 1 plus 1, you can directly write 0. But the thing is carry will be 1. 1 plus 1 plus 1. You can write 1 as the answer. But you have to carry 1 bit for the previous calculation. Previous means in the next calculation in this example, you have to carry the value. So we'll do an example, then you'll get the clear knowledge about this addition part. So 1 plus 1, that's equal to 0, but the value will be added with the next one. So 1 plus 1, that's equal to 0. So 0 you have to write. Then 1 plus 1, again, you have to add the remainder part as 1. So 1 plus 1 plus 1 in this calculation will be here. So 1 plus 1 plus 1, you can write 1 and the remainder will be 1. The carry part will be 1. So 0 plus 1, 1. Then the carry part is also here. No? So 1. So 2 is here. You have to write 0 and carry will be 1. Again 1 plus 1, the carry part also there. So 1 plus 1 plus 1. So 1 you can write. Then carry part is 1 is remain. So 0 is here, but the carry part is also there. So 0 plus 1, 1. So 1 you can directly here 1. So this will be the answer of this binary calculation. So what you have to memorize is, once you are having 1 plus 1, that's equal to 0, right? 1 plus 1. In decimal number system, you can come with the answer as 2. When you are having answer is 2, you can write 0 and remainder or carry part will be 1. So once you are having 1 plus 1 plus 1, you can write answer as 1. Then the carry part will be 1. So these are simple things. So again, we'll do a calculation in binary part. 1, 0, 1, 1, 1 in binary. Both numbers are in binary format. So 1 plus 1, directly you can write 0. The 1 will be remainder. 0 plus 1 and the remainder 1, then 1. So 2 will be the answer. So you can write 0. The 1 is carry. So 1, the carry part also there. So 1 plus 1, that's 2. If you are getting 2, then you can write 0. 1 will be the carry. So 1 you can write here. So this one will be the correct answer. So this is the binary calculation addition part in number system syllabus. So if you are worrying about the octal addition, that's very simple one. We can calculate the octal numbers with the base of 8. So I'm writing as a third example here. 173 and 16. So this is the number in octal. So once you are adding 3 plus 6, in decimal that's 9, right? But 9 you can't write here because in base 8, 1 to 7 digits only you can represent here. So 6 plus 3 is equal to 9. So 9 that will be divided by 8. So one time it will be totally divided and the remainder will be 1. So you can write as 1 here because remainder is the thing you have to write in this value. Then 1 will be the carry. Then 7 plus 1, 8. With the 8, you have to add this 1 carry value. Then answer also 9 here. So 9 means you can write the remainder as 1. And again the carry will be 1. So that one, and here also you're having a 1. So 1 plus 1, 2. 2 you can write in base 8. So 2, 1, 1, base 8. This will be the correct answer. Again, we'll do another example with octal number system. 1, 1, 3. Again, 7, 6. So both numbers are in base 8. 6 plus 3, 9. Again, we are getting the 9. Then you have to divide by 8. Then one time it will be totally divided. Then remainder will be 1. Then remainder 1 will be written. Then 7 plus 1, 8 with the value 9. Then again, you can write as 1 here. Then 1 plus 1, it will be 2. Like that way, simple calculations we can do. But I'm doing another example with different numbers. That means 3, 6, 5. And I'm writing as 6 and also 7. What about these calculations? 5 plus 7, that's equal to 12. But 12 you can directly write. You can't write as directly. Then you can divide it by 8. So one time it will be totally divided and the remainder will be 4. You can write the 4 here. So 6 plus 6, 12. Then the 1 will be added that value, then 13. So 13 will be divided by 8. So the correct answer will be one time it will be totally divided. And the remainder will be 5. You can write the 5 here. Then 1 will be the carry one. So 4 plus 1, 3 plus 1, 4, you can directly write as 4. So base 8. So this one will be the correct answer. In octal number systems, we can do like these calculations. So if you are doing some calculations in hexadecimal, we can move with the number. That means, okay, 7, but I think example number 1. Okay, I'm starting with 1. So 1 CB plus 1 3. What about this calculation? In base 16, we can add these numbers. B means, generally, you know, A means 10, B means 11, isn't it? So B means 11. Then 3, you have to add, the final value is 14. Then directly you can't write the 14. Sorry, we can't write, right? Because after the 15, we can't write. So 14 means what? 14 means E. So you can write direct value as E here. Then C means 12. No? Then 1, 12, 13 will be the correct answer. 13 means D. Then 1 will become as a directed one. Then 1DE is the correct answer for this calculation. So if we are getting the numbers from 0 to 15, we can directly write. But the thing is, if we are getting the 10, we can write as A. Once we are getting a value as 11, then we can write as B. So like that way, we can calculate. We'll do some example in hexadecimal as another. So 1CD and F9, I'm writing as this. Base 16, base 16. So once we are calculating this one as addition one, D means 13 and 9 we have to add. So 2, 2. 22 is the answer. But the thing, 22 you can't write as direct one. Sorry, 22. You have to divide by 16. One time it will be divided as total. Then 6 will be remainder. So you can write as 6 here. Then the 1 is the carry, right? We have to mention also. Then C means 12. F means 15. So the correct answer will be 2, 7. Remainder also here, no? So 28. But 28 we can't write directly here. So 28 will be divided by 16. So one time it will be divided as total. Then the remainder will be 12. So 12 means you can write as C here. Then one carry bit will be added with this one. So 1 plus 1, 2. So 2C6 will be the correct answer in this number system regarding to the hexadecimal calculation part. So these are the things we covered in this video session. That means number systems addition in different number systems like octal, binary, and the rest hexadecimal part. So we'll see in next video with the new concept. Thank you.